Welcome to this great talk, or this talk that we're going to talk about on DevSecOps, the tale of business, engineering, and people. And Sean put on some music there for us that is kind of be illustrative of the talk. I'm from Texas. I'm from Austin, Texas. And so he was like, well, let's play some country music. And I was like, I know just the song we need to play. So there we go. He introduced me. He said that I was the dev advocate over at Verica. I also have some LinkedIn Learning courses, and I help run the DevOps days and serverless days in Austin, Texas. And we're about to have a DevSecOps days in Austin, Texas, and we'd love to have you come down there and check that out. I'm also working on the DevSecOps handbook, and it's in progress right now. We'd love to have some feedback, and I'll have a thing on the end of the presentation about that. Well, this is like one of my specialties. It's like maybe my favorite O'Reilly book, and I find this is like I like it in depth, right? You're like, that's what I do. I'm on Slack all the time. So if you find that to you, you can get the slides right now, and you can by sending me an email at wickett@verica.io. My out-of-office autoresponder will have it in there, and it'll have a link in there if you can download them if you like, and check it out. So if you suffer from me with that same syndrome, then there you go. Well, and I'll have one slide in here to tell you what Verica is, because we're a brand new startup, and we're an enterprise platform for continuous verification using chaos engineering principles to take a measured and proactive approach to preventing availability and security incidents. So we're really excited about that. We're really excited about the process of where we're going, and maybe some of that will come out as we go through. But before we get started, and before we start talking about DevSecOps, when we talk about anything, I thought we could talk about something a little more historic, something that happened a long time ago. And I wanted to originally call this talk like a tale of money, chaos, and woe. But then we kind of changed it up a little bit. But in the year of 1896, almost to the day, this coming Sunday is going to be the anniversary. There's this man who came up with this idea that they were going to ram these two trains together as a demolition experience. So this is William Crush. William Crush is a ticket agent for the Missouri, Kansas, Texas Railway, often referred to the Katy back in the day. And William Crush was just a passenger agent, and the Katy knew that they wanted to expand their influence and their reach across the state of Texas, and they needed some promotion to do that. And Crush had kind of been watching the newspapers. He'd seen some other things going on in the world, and that was interesting. He saw these other people trying to run trains together, and he knew that they had some spare engines laying around that they were going to be retired. So he thought, well, why don't we get those, and for this promotional purpose, like we're gonna jam these trains together. So it's gonna be like a demolition derby, but for trains. And this was not, like I said, wasn't the first time that anybody had come up with this idea, but this is the first time that I think that we saw it be successful, sort of, in a way. But the idea was happened in Ohio several times, but they struggled with the idea because they would try to charge tickets, but you're ramming two trains together, so you really have to block off a big area, and so people were climbing up in trees to watch it, and sometimes they wouldn't even end up ramming the trains together because the financiers are like, okay, we don't have enough ticket sales for this. So Crush's innovation in the whole thing was the freemium model. He's like, we're just going to make the whole thing free. If you want to come and watch these trains, just come on down. We got a spot for you. Texas has got a lot of land. He found a place with some good hills around it that all the crowds could gather with a big kind of a natural, almost like a natural place to see this. And they ran the trains line through there. So overnight, the railway loved it. The Katy's like, all right, you're going to jam some trains together. This is going to be a big promotional event. They booked it 4 or 5 months out. They started working on it. Oh, and the kicker here was, he goes from this passenger agent to big tent promoter extraordinaire. And they said, well, this is a great idea. We're just going to name the town right after you. So they called it Crush, Texas, and it was a city for a day, all of one day. And they sold these tickets from Dallas to Crush, Texas. Now Crush it was located right outside of West Texas, which it sounds like a direction, but West Texas is actually a town, and it's in between Austin and Dallas, if you're thinking about that. So the idea was, we're not going to make money on the actual event, we're going to make money on all the ticket sales. And so they sold a lot of tickets. They sold so many tickets that it was the largest exhibition in the state of Texas that had ever happened. And 40,000 people, the estimates range from 30 to 50,000, but a lot of people think it was around 40,000 people, came to Crush, Texas to watch this whole thing go down. So Crush, put on his hat and he said, all right, well, what are we going to do to make this happen? It's going to be kind of rowdy. I mean, 40,000 people even today, that's like RSA-sized event, right? So that's a big event. So we're going to need some police officers, and they built a makeshift jail. They drilled a bunch of water wells to help make sure no one got dehydrated or anything. Brought in water tankers from outside, brought in some concessions, some lemonade stands from Dallas. I think 10 of those were brought in from a guy up there. Preachers and politicians descended on there. There was a midway that had games, cigars, there was a carnival, all sorts of things, big festivity. So on the business model, didn't stop there. So he had the ticket revenue, he had the concession revenue, and then now he added advertising revenue. These are the two trains that he was going to jam together. And you can see over there on the far right-hand side, there's some advertisements on those. We can't see it too clearly, but he started selling banner ads. If we were to think about it in our parlance, right? And Crush was concerned about safety. He understood this is a thing where people could get hurt, not just from getting dehydrated and standing out there watching these trains get jammed together, but boilers explode. This is a shot of a train engine in the 1850s where just the boiler exploded. And at that point, you may be thinking, well, what's going on here? This is all the pipes kind of running vertically. They kind of convey all the steam. That steam gets turned to power to push the wheels. And this would just happen sometimes, like you're just driving down the on your way, and you hear some clunk clunks, and then all of a sudden the train explodes, and now you're in a kind of a dire situation. So it's not like the idea of boilers exploding were novel or new, like Crush knew to think about that. So we had engineers come and look at the boilers, and they said, yeah, these look good. He laid 4 miles of track, because he also didn't want the catastrophe to spread outside of the two engines. He didn't want it to take down the train tracks. He wanted to be able to still have service to and from the event. So he laid 4 miles of brand new track that they were going to run these trains together at. He kept the crowd back at 200 yards. He let the press come in a little closer at 100 yards to get better photos. And then word got out about this event. And so he went to a big promoting type role. And Thomas Edison wanted to film it. He had a kinetoscope. This is the device they used to display it, but he took a kinetograph there, not Edison himself, but one of his students, I think, or one of his employees. And so at 4 p.m. on September 15th in 1896, the trains were released to come together. One of the reporters that was on the scene, they said, the rumble of the two trains, faint and far off at first, but growing nearer and more distinct with each fleeting second. It was like the gathering force of a cyclone. And they captured this image right before the trains collided. And it's a pretty great image considering the technology of the day, right? And you see this. And they collided at a speed between 90 miles an hour and 120 miles an hour. The estimates kind of range on that. And it was a big explosion, really big. But 1 second right after that initial explosion, there was a subsequent explosion, and both of the boilers in both engines also exploded. And we showed a picture of the boiler in real life, but here it is, a diagram of it. And it was common for if you got any cracks on the along the walls or any of the welds, or if there's any rust inside. And so as I started researching this, I started kind of geeking out. I was like, well, how do boilers explode? Well, how does this all work, right? And so you kind of go down the process, but you see this is actually the boilers. This is not just the train, exploding. This is the boilers exploding, and now propelling all sorts of shrapnel across the sky. And it's the steam and the iron and the wood just filled the sky, and it started to rain down on all the crowds. Of course, they're Texans, so after the dust settled, they wanted to go get a souvenir. So then they rushed the scene of the accident, not to be held back. And then they also got burned from that because it was still hot, you know? So injuries were sustained on all sides. And there's estimates about 4 people that died. Other aftermath and fallout from this, Crush was fired. Widespread injuries during the incident, then more injuries after the incident, after everybody's trying to collect their souvenir. Crush, Texas was immediately shut down. The Katy lawyers and representatives were brought in, and they started to work out the settlements with everybody and get all the details done. This is a couple days later when they say, all right, we got to pull up the tracks. And now when you go there, there's nothing there. Like there's nothing in the field. And we have a sign, and I think it was in the 80s. They had the sign out kind of in the middle of nowhere where the site actually was, right outside of the I-35 in Texas. But then they ended up moving it into the town of West because like no one ever actually went out there. It's still just a big empty field. So this is what we've been left with. So more fallout happened in the days following. So Crush later was rehired by the Katy, and he worked there for 44 more years. So the firing didn't stick because it turned out that no one really blamed him for it, and it was just sort of more of a political move to cover their bases there for the train. And after this happened, it was actually deemed as a success, oddly enough. Demolition derby via trains started to become a national phenomenon. Hundreds of other cities, like you would think like, okay, cool, they're gonna say, hey guys, stop doing that, like stop ramming trains together. But no, they decided like, no, we're gonna keep this up. But in the events, the 100 of events that happened post-Crush, all the boilers held. So it's not like it was a crazy idea to do this in the first place. Like, it was possible to do this without having mass chaos and death and all that. So, all right, in all this, what can we learn? What is it? These are some things that I took away from it. First off, like we have chronocentrism, which we think that our generation and our time we're smarter. Because when I first started reading this and started going through this, I read about it, and I'm like, oh yeah, like why would you do this? Like that's a bad idea. Also, engineering is hard, right? We think that they obviously got the engineering right to get the crash to happen in the right spot where everybody could view it, the photographers could take the pictures, they could try to video it for the first time, which it would have been if the video had survived, which it didn't, from Edison. It would be the first like special effect ever recorded. Also, blame is really easy. Like you can, just fire somebody, or you can sort of, use that as an option to deal with the problems. But it's not really a fair way to deal with it. And it also taught me like root cause is a myth. Like who is the main cause for this? Like was it Crush? Was it the people at the Katy who approved the whole event? Was it the engineers who evaluated the engines to say that they were safe to do the crash, or was it part of society like wanting to see this kind of thing? It's hard to analyze in this sort of situation who really would do that, who is really at fault in that scenario. And when you're thinking of socioeconomic and sociotechnical systems, like that sort of overlays and overmaps to that. So I also believe that like breaches and failures or accidents or whatever, that doesn't stop business. And we saw that like they continued to keep on going and have some progress where they're able to have a lot more of these type of events later on in the late 1800s and be successful. And also the last thing I came away from this is that experimentation and learning are critical for us. And if they could have done some sort of smaller scale experiment, like that would have been a better play there. Okay, cool. Well, yay trains, right? Okay. Yeah, well, again, I was hoping that would be funnier. Cool, so DevSecOps. Well, where does this all fit in with DevSecOps? And like we have all these learnings, we can think about this event that happened, 100 years ago, 123 years ago. But what does that really mean for us? What does that mean for us today? How do we think about this thing that we're left with that we're now dealing and talking about called DevSecOps? And I think that I'd like to, in the words of my good friend Josh Zimmerman and his DevOps Deep Thoughts, I thought I'd like to think about what DevSecOps means. Maybe in order to understand DevSecOps, we have to look at the word itself. Basically, it's made up of 3 separate words: de, vseco, and ps. Well, what do those words mean? It's a mystery. And that's why so is DevSecOps. And so we're left with it, and we're thinking, why do we have this? What does this mean? Well, first, I think we could look at DevOps and understand how we got there, and that might inform us like why we think DevSecOps is important and how we can live with it. So this is going to be a real special time for us. First, we had the cloud, and it was great, and we saw it and we loved it. And the data, it just got so big, and we were thinking, this is awesome. Now our new OSI model is really a lot easier to understand, which this is my favorite part of it all, because I was really always struggling before. And then we have this thing called serverless that came out that let us move our consumption and payment closer to what we're actually using. Tom Limoncelli says this. He says, DevOps is an inevitable result of needing to do efficient operations in a distributed computing and cloud environment. So when we have a single person managing 10 and hundreds of computers, it's fine. When you're doing thousands, not so fine. You need something different. But Damon Edwards always reminds us that DevOps is not a technical problem. DevOps is a business problem. I like to think of it as an epistemological breakthrough where you join two disparate groups of people around a common problem. DevOps was needed to fix also the inequitable distribution of labor that we often experience, where you'd have 10 developers to 1 operation person. And I also think that DevOps is just another waypoint. You could think of it this way, as it's just another waypoint on the journey of Agile across the business and to find value. Well, okay, fine. Maybe you're convinced, maybe not, but that's what DevOps is. But why do we need DevSecOps? Why is it important? And I asked myself the same question. I thought, this is just going to get out of control. Like we're going to be stuck with this scenario, and it's not going to be great for us. But a little bit of empathy also kicked in, like figuring that security is finding itself in the same position that operations did in the early movement of DevOps. So for every 100 developers, you'd have 10 operations to 1 security person. There's a natural siloization that happens whenever you do this. People are throwing things over the wall. And security-like operations really struggles to provide value in many organizations. This book, Steve Beloven, that he wrote, it's called Thinking Security. And there's two quotes that I almost like to always use in any presentation I give, and this is one of them. He says, companies are spending a great deal on security, but we read of massive computer-related attacks. Clearly something is wrong, and the root of the problem is twofold. We're protecting the wrong things, and we're hurting productivity in the process. Does that bother anybody here? Does that hit home? Yeah, right? It's like we're not stopping the problem. The breaches continue to get worse, and we're slowing everything down. And the business doesn't always see security as on their side. The other one that I like is Michael Zalewski's book, The Tangled Web. In the first chapter, second chapter, he walks through a history of computing and says, and kind of goes through in where security was in the 50s, 60s, 70s, 80s, 90s. But in the 90s, we kind of hit this speed bump, and we have this quote. He says, security by risk assessment introduces a dangerous fallacy, that structured inadequacy is almost as good as adequacy, and that underfunded security efforts plus risk management are just about as good as properly funded security work. And I read this quote many years ago, and it's always stuck with me as just we don't want to do that. We actually want to do good engineering work. We don't just want to just buy insurance policies or do actuarial duties to deal with our problems. But that's what we're often left doing. Late last year, SANS came out with a report for the DevSecOps survey, and it said while engineering teams are busily deploying leading-edge technology, security teams are focused on fighting yesterday's battles. Does that hit home with anybody? Yeah. And that happens, right? And I know people that go in on security engagements or just engagements for consulting, and they're like, they're talking Kubernetes. They're like, well, what do you do for security? They're like, yeah, we don't tell the security people about our Kubernetes deployment. They're like, why? It's like, because they'll get all up in our business, and we don't want that, right? And it's like, okay, that's a real problem. And I think it's because one of the things we often feel with security is that many security teams work with this worldview where their goal is to inhibit change as much as possible. And it's kind of reasonable. I mean, we're dealing with, it's reasonable to see why we need this, right? We have new technology that's coming about, and we have an increased organization focus on software delivery. And I think that's why we really need DevSecOps. Like, we're trying to produce at a faster speed, and we have a lot more technology involved, and so we need something different. And so this is where I think that we need to think of this new breed, this person as the DevSecOp. And I'd like to talk like what I think the DevSecOp is, talk through a framework that I've worked on for that. But it's not a tool. It's not, you can't buy it over in the expo hall. And I mean, I know some people would convince you otherwise. But you can't buy it over there. It's not a CI/CD pipeline that maybe has some security tools, jammed in there. And it is something that we become, and it's something that we are dealing with as we kind of wrestle with the idea of DevSecOps. And I like to say it's an inclusive person participating in the movement of security into DevOps. So I have this framework that I've been working on. It's the Measure framework. And we're going to punch through each of these, and I don't want you to take this as like you have to be doing all 7 of these to be fully like DevSecOps. Not even all of them will fit, but in the spirit of like John Willis and Damon Edwards when they came out with the CAMS model, which is the culture, automation, measurement, and sharing, and then later CLAMS because they added lean in there. I wanted to give us a way to think about how DevSecOps works. How we can sort of rationalize it when we're dealing with it in our business, make business cases for it, and put effort and engineering behind different areas of our software delivery and development. So what does Measure mean? It means maker-driven, experimenting, automating, safety-aware, unrestrained sharing, ruggedizing, and empathy. All right, are you guys ready? Yeah, okay. Thought that'd be more exciting, so we'll see. It's good. It's the afternoon and all that stuff, and I already gave you the slides, so you're like, I know where you're going with this. So, okay. All right, so maker-driven. Let's kind of punch through a few things on this. All right, so first, we're software engineers who specialize in a specific discipline, security. That means one thing. That means that security must be able to write code. And I've said this before at a conference, and then I got like a lot of hate messages on Twitter about it. And in the end, so if you're hoping to do that, like that's great. Take a picture of it, put it on Twitter, say Wickett says security must be able to write code, and I'll be dealing with that for like months to come. Appreciate it. Thanks. But we could really think about what it really means. Like, you're in the process of delivering software. You're in the world of software, and you don't know how to actually like create software, to be a part of the process of writing software. Like, that should be concerning. Like, security should know how to be a part of this. Operations had to do the same thing. Operations used to say, well, I just run the Nginx server and I don't deal with any of the other problems, or I just run the Tomcat or whatever. But all that stuff had to break down. I'm not saying security needs to lead the process. I'm not saying like security's main job is to write code, but being part of the software delivery process, that's really important. And I don't know why this is a hot take in our industry, but it seems to be, and we'll see. And maybe in 5 years, I'll be wrong, but I think that in 5 years, I won't be. If you try to get a job at like one of those like startups or not even startups, like any security job right now that's like DevSecOps, like they're gonna expect you to write code, right? I mean, that seems pretty reasonable. And there's a lot of resources available today. These are my 2 favorite books on writing code I don't leave these, keep these right on the desk. So, in the end, like we have to think about that. We have to internalize this as like security is part of making. Like we're a part of the building of the stuff, and we're already somewhat developers. Operations was like, yeah, I do already kind of know a lot of YAML. Well, I guess there's other stuff back then, but I'm dealing with all this kind of code-like stuff, and security is already using those DSLs as well. Like we're dealing with like writing those WAF regex rules by trial and error. Okay. You haven't lived that, or you're like, oh, I don't want to live that anymore. So, the part is, the point is that the security team has to participate in the software delivery process. This is also an empathy building exercise because it provides you familiarity with the tools and you're able to move up and down the pipeline. You're able to shift left and shift right and all that sort of stuff, but you're able to participate in that process. Another thing that I'll say as part of being maker-driven is that to realize that a bug is a bug is a bug. Like to internalize that and understand that when we think about security bugs, they're just regular bugs that can be exploited. And I know DJ Schleen has a lot of comments right now on defect density, and I'm not even going to talk about the importance of it or how maybe it's a misleading metric or any of that sort of stuff. But I do want you to think about this. All computer science papers that kind of talk about defect density or errors per lines of code and all that sort of stuff, the studies range from like 0.5 to 10 per 1,000 line of code. The important part is that defect density is never 0. Defect density is never 0. And now whenever I'm dealing with like all my framework and my dependencies and all the stuff that it gets bundled into my software, the 500 lines of code or 1,000 lines of code that I write can easily turn into 400,000 lines of code, 500,000 lines of code. Okay, so my hot take on all that is that we just can't train developers. We can't just say, well, we're just going to put you through the annual training and like you're going to be good to go. Good luck with that. And we can't train developers to write secure code, not because developers are stupid or not because the training doesn't exist or we didn't buy the right product. It's because you can't teach humans to write code that doesn't have errors. We've been trying to for a long time, and there's no way to do it. So instead, I think we should focus on the ways that developers use to deliver code that is like less error prone and more resilient to faults. So they do test-driven development, behavior-driven development. They put meaningful comments in their commits or in the code. They think of like code smells and patterns and refactoring and instrumentation and observability. And they work in ways that security could easily fit our tooling and our processes into that, right? Okay, so where are we left with this? The Agile Application Security book says the goal should be to come up with a set of tests, an automated test that probe and check security configurations and runtime system behavior for security features that will execute every time the system is built and every time it is deployed. So, all right, that's how we can think about it. My last point on this measure piece is that security is inherently connected with quality. The DevSecOps community survey in 2019 found that 1 in 4 developers believe that security is synonymous with quality, and we think that's going to continue to grow over time. Like that is one of those things that people believe about their software, and they want to have high quality software. So being maker-driven means to see security as part of engineering, view quality as a way to bring security in, and use code and not vendors to solve problems. Don't tell people in the expo hall that I said that last bit. Okay, so experimenting and how we can learn from our experiments. So what are some benefits that we can have from doing experiments? They can be measured and repeatable. We get results based on our needs. We have actionable outcomes. And we can look at, I like Aaron's quote. I work with Aaron Reinhardt. He says this, security incidents are not effective measures of detection because at that point, it's already too late. So what if you're able to sort of do some experimentation and learn like what are some common causes or common problems you have? Shannon Leitz and I gave this presentation at RSA in 2019, and some research that she did was taking the OWASP top 10 and moving this across, that's the blue dots there, and then breaking it down into attack vector or types of attackers. And it's split up there with scanners, paid noise, and then advanced adversaries being different colors. The point is that you kind of got to watch the whole talk, and she really is able to build all that out for you. But what your system actually experiences is different from what we predict with the OWASP top 10, and it's different by your vertical, by your company business unit. So that's something that's worth thinking about and understanding. What am I actually being attacked with? Okay, so know the most likely attacks and how to measure abuse and misuse. Zane Lackey over at Signal Sciences, he says, we can't cede home field advantage. And I like that, because a lot of times in security we say, well, you can't make a perfectly secure system. It's like, well, maybe not, but I know my system better than anybody else, or I at least could, way better than the attackers could. So why can't I actually understand it a little more further? So, but experimenting necessitates that we understand our steady state. So I think there's a couple resources for you. Any of the stuff that Shannon Leitz does, her Twitter handle is DevSecOps, and there's a talk which is very similar to that slide that I showed for 2019 RSA that's hooked in there as well. So, all right, automation. All right, this is the piece that I think is pretty interesting to a lot of us. This is what we think about when we start thinking about DevSecOps. We think about the pipeline. This also comes from that DevSecOps survey. But you can break it up, all the phases of the pipeline, and you can see those without a DevOps practice. Those are the kind of the orangey looking red color on there for you. And those are much lower than people that have implemented application security practices, which is then they're kind of called the DevOps elite, and they're like that purpley blue color. But I was really just encouraged across the way, like a lot of the phases of the pipeline, people are implementing security tooling and security testing. Now, if you attended Derek's talk, you could see that like survey data versus like reality and code may not be as great as you think. So you might want to hit him up for some things on the slides for that talk. But I also thought it was cool, like web application firewalls, container application security, open source governance, static application analysis, dynamic application analysis. These are tools that we've had for most of them for a fairly long amount of time. And we see that those with DevOps elite practices far and away have them installed across in larger usage across our organization. All right, so also with automating is we can think about how much we deliver. How often we deliver, how security plays inside of that. Jez Humble in his book, Continuous Delivery, says continuous delivery is how little you can deploy at any one time. I often think about this as cycle time, and we need to optimize for total cycle time, and that means from time of code commit to like running in production. You want that to be as small as possible. A lot of people will recommend like the coffee test. So if it takes longer than 5 minutes to go from code commit to running in production, you might need a refactor. You need to include your security tests in that as well. There was a great talk yesterday about on the pipeline and how to do that, and like how you can fork out like long running jobs and things like that. But whenever I was over at Signal Sciences, we did 15,000 deploys in 3.5 years. And you know, fairly small team, fairly small startup, but we were moving quite rapidly. It's because we constantly were always optimizing for total cycle time. We would have meetings where we'd come in and be like, all right, here's the build, it's like 6 minutes today, like how can we get this to go faster? And so everybody would have to like, you know, count off for like what they're doing, and we would look at the security tests along with everything else. And it wasn't the answer to drop them, it was like maybe run them in a different cadence, run them in a non-blocking mode, maybe move them to the deployment system, which we did as well. But putting security in the pipeline, you know, you can start kind of small, right? You can do, I mean, I guess SCA is not that small, but you can put language linters, you can do some like GitHound stuff, putting some scanners in there, using Gauntlet, putting monitoring and telemetry in there. Those are some ideas for you. There's been a lot of great talks at this conference already about how to do a lot of that stuff. But now we're able to treat deploys as standard routine changes that have been pre-approved by management, and they don't require this heavyweight change approval board or anything like that. So that's really refreshing, and that means like security can now like unlock that whole like going fast part, right? Maybe we may or may not be like stopping all the breaches, but at least we can unblock the business, and hopefully we will like bring down some of the breaches as well. So I have 2 courses that I've written on this topic. One is DevSecOps, Building a Secure Continuous Delivery Pipeline over on LinkedIn Learning. And the other one is an automated security testing, which is more of a deep dive into the actual code side. But if you're interested in those, go check it out, or hit me up. I might be able to get you like free access to it. All right, the next one here, S, safety aware. Do we understand like the difference between simple and complex systems? A lot of times our human brains will often try to take a complex system and we try to make it a simple system. But when we say simple, we mean they're linear in nature, they're easy to predict, and something that we're able to comprehend in our head. Like it's something we're able to keep our mental model, if you will, and understand. But complex systems, they are nonlinear in nature. They suffer from what can be called like the bullwhip effect. So a small change at one end of the whip creates sound barrier breaking at the other end, right? So completely different results can happen out of the system. They're unpredictable in nature, and there's no mental model available for them. So with all this, like we like to abstract complexity away, and this is something we do, in code and frameworks and other things like that. But we do it with we try to think of human beings like we have a mental model or the way we deal with other people. We do this with society, psychological issues. We do it because we can't handle all the cognitive load of keeping it all straight in our head at any one time. And so, and we deal with that same problem through software, and we just add another layer of abstraction, right? Like that's always the quickest way to solve a problem. It's like, I bet some YAML might fix that. I thought that one would be funnier. So good. We're 2 for 2. Great. Maybe I haven't been burned enough by YAML. I don't know. But so, as we think about complex systems, then we now have to think, if we don't actually understand the system in any sort of real way, why do we think that we can arrive at a root cause in a failure type mode? And so I think root cause, specifically in a complex system, is a myth. Because we lack the full picture. Complex systems aren't linear. This is part of our blame culture that we live in. You can think about our example with William Crush, right? It's like, and you're fired. It's like, well, at first blush, like that seemed like a good idea. But later it's like, well, I mean, all the steps were taken. Maybe somebody else should have been fired, right? It also lacks the context and forgets the organizational decisions around the whole event as it happens. And it really puts a focus on the specific, the two trains crashing into each other, the explosion, rather than the whole situation and kind of lead up to the whole event and how it all unfolded together, right? And Sidney Dekker has a great book called Drift into Failure. And he has this quote. He says, "Drifting into failure is a gradual, incremental decline into disaster, driven by environmental pressure, unruly technology, and social processes that normalize growing risk. No organization is exempt from drifting into failure." We can think about the Boeing 737 MAX. We can think about how, now where we have the MCAS, it commands the trim, so the pilots don't have to worry about it for like a larger airplane. The thing is, the MCAS is just software. Like the software was doing all this without the pilots like really being able to detect what was going on, and they were being told. The software was fighting the pilots silently, and the pilots were having to deal with this all this information in a context where they were told that everything is like a normal Boeing 737. And I don't know if you've ever researched this or seen any of the info on this, but like the crashes were happening at 3 to 5 minutes after the planes take off, something like that. So you were putting your operators in a high-speed decision-making environment, in a very up-tempo environment where they have to figure out what's going on, and all of the software is telling them that everything is fine. And software is eating the world and is taking over our systems. So we're our physical systems as well. So now we're living in this complex environment where we're dealing with this. And Sidney Dekker's quote goes on to say something else about complexity. He says, "The growth of complexity in society has gotten ahead of our understanding of how complex systems work and how they fail." So it's kind of concerning, but I was like, I don't know, maybe here I'll pull down a serverless app. And I was like, oh, that's cool. I can understand that. I get it. Like, where's my 3-tier web app, right? It's like that. At least I could put that in my brain and figure out the blinky lights on the database are not good. It's like things aren't working in your web app. You're like, I have no idea. And this was whenever I went and downloaded this is an easy, getting started guide of how to use Lambda and stuff. It's like, okay, cool. I like what my friend Matt Stein says. He's like, it's becoming clear to me now. Software. Probably a mistake. I don't know exactly what he was talking about, but I like to think he was talking about this. So we're leaving the operations and the security team, we're putting all this burden on them to rationalize our system models and to keep all this in their heads. So that is not good. And we have to think about our failures as a system problem because we don't have enough safety margin. And that's a quote from Adrian Cockcroft. And we have to also reckon with this fact that now we're dealing with systems that are complex. They fail. It's just a part of their nature. And Sidney Dekker says failure is an inevitable byproduct of a complex system's normal functioning. Like it's an inescapable thing. So how does security fit in all this? Well, security can be part of the story of adding safety margin in. We can add telemetry and instrumentation in. We can participate in blameless retros, blameless retrospectives or postmortems or however you think about that, but specifically on the blameless side of things. And I have some more stuff in the empathy section to talk about that later. But if you're interested in any of this, if you're kind of piqued at like, okay, the safety stuff like sounds oddly familiar and oddly scary to the stuff that I deal with in security, here's some links for you. I guess the text there may be hard to read, but check these out. There is a human error video series that Aaron Reinhardt turned me on to by Sidney Dekker that I think is like really great. And then if you only have time to do one thing or read one thing, at the very bottom there's Richard Cook's paper. It's called How Complex Systems Fail. It's pretty short. Richard Cook is a medical doctor, and he wrote this thing about how complex systems, the human body, failed. But when you read it as an IT person, you're like, holy smokes, like that sounds exactly like the stuff that I deal with on a day-to-day basis. And now Richard Cook goes around speaking on this, and he'll speak at a lot of IT conferences nowadays because of kind of so much overlap and so much learning that we've gotten out of that. Okay, well, let's move along. So let's talk about unrestrained sharing. Unrestrained sharing is something that may feel a little weird to security, but Patrick Dubois, when he first founded DevOps and he first kicked it off, I think it was like 2011 or 2012, he did a enterprise, like can DevOps work in the enterprise? And he did a whole, I think it was a Cutter IT journal on this. But one of his quotes is that culture is the most important aspect to DevOps succeeding in the enterprise. And if you go back in time and you were like to ask anybody in DevOps, like, what is DevOps, especially in like 2010 or 2011, they would just say, it is a cultural movement, stop, right? And then you're like, well, that's not going to do it. But they were so worried about like people taking DevOps and then equating that with some sort of software or tooling or job title or something like that. Eventually we did all those things because we're humans and that's what we do. And they all of the original DevOps OGs were like, that's going to happen. So we don't want to do that, but it's gone ahead and happened anyways. But I do still believe that we originally focused on culture for the right reason, and we still need to continue to keep that as a heartbeat for DevOps. And because DevSecOps is just an extension of DevOps, we need to think about that as we kind of move forward. Rich Smith, he says, former security director over at Etsy, he says, a security team who embraces openness about what it does and why spreads understanding. So unrestrained sharing affects our culture. But it goes against a lot of our standard operating procedures. A lot of times I think that it'll feel uncomfortable to you to share. But sharing naturally breaks down silos. It's like, oh, only the security team is allowed to log into this one security tool. Like developers should never have, information about this because, cloak and dagger type stuff. Well, that's probably wrong. If you have thinking like that, you need to try to come up with ways to maybe sanitize some of the data or whatever, but you got to figure out ways to create sharing across those groups. 4 keys that I think are important for culture are having a mutual understanding, having shared language, having shared views, putting collaborative tooling in place. And as those things kind of develop, you start building culture that is really useful. I like the DevSecOps survey because one of the questions that they were asking developers, like, hey, what do you think about this, security, and they were trying to going back and forth on this. But one of the answers was, we don't even really know what security wants from us. We have no idea what they want us to do. And it didn't matter if they were a DevOps practice or immature in their DevOps practice. They were just flat out a fifth of them are just confused. Security has not brought them in the process. So I think security shares through making stuff, the invisible stuff visible, adding security observability, finding ways to put in APIs or webhooks or dev tooling or any of that sort of stuff. And you can't leave out the auditors, which is, I know it's really tempting to do. Sorry if there's any auditors in the room, but I think it's important. There's a project that we started working on, I guess about a year and a half, 2 years ago, called Dear Auditor, and it's over at dearauditor.org. And this is a love letter from DevOps to auditors. And in it, we apologize, which sometimes you have to do. And we said, hey, we started this whole DevOps thing, and we didn't bring the auditors around, because I don't know if anybody go through like an audit or compliance thing, and you're like, you start talking, and the auditor's like, that is not going to work, and you're like, we have a huge disconnect here. So I've experienced that, and so we built this, and then also associated with this is a DevOps controls matrix. So if you want, it's open source. Check it out. We're still working on it, still putting some stuff together on this. But yeah. Okay, some resources for unrestrained sharing. I think the Phoenix Project book, if you haven't read it, I know it's kind of canon now, but definitely check that out. That book, the Agile Application Security book, has some context on this as well. And then Dear Auditor, I think, is a great resource, or I think it could be a great resource if we can kind of get more work behind it. Okay, let's talk ruggedization. What do we mean about ruggedization? It is running everywhere. Yeah. So I think one thing, like the one way we build something that's rugged is by like knowing what we have, which is kind of a novel concept, right? So like we have our bill of materials, and so we get to know what is inside of our software. Another thing that you can think about for rugged or ruggedization of software is that we favor short-lived systems. The old saying of cattle, not pets. Although I've heard some people tell me they don't appreciate that, and there's some other ways we could think about it, but I'm like, I don't know. But Sunil Yu, he has the DIE framework, and he's working on a paper, and I'm not sure if it's out yet or not, but it's proving that just by having these three attributes in your system, you're by the very nature mathematically more secure. So if it's distributed, immutable, and ephemeral, if you have those three things in any combination, you are going to be more secure. So it's a pretty cool research and really interesting. So as that comes out, or kind of be looking for it as you can find it. But where is ruggedization going? Like we can talk about other type of stuff, but I think there's two key areas where I believe ruggedization is happening and where we're going to see this grow over the next year. First, I think deception. This is, I know we had like all the honeypots and all that stuff like 10 years ago, but I see people really like industry-leading firms that are working on doing deception tactics that are making a huge difference. They're putting honey pits and tar pits and man traps and all sorts of stuff. It's simple to get started. You can like just spoof out some some hidden HTTP fields or something like that, and see if those get called, and then you can flag it. Some good projects on this. HoneyPie is an open source one. Deception Logic is a friend of mine's company is trying to get off the ground, so it's kind of cool. But thinking through like how do we build better deception into our systems as ways we can get security telemetry and instrumentation out and to the developers, and we can sort of play that out. So the other piece I think is also chaos engineering, which is somewhat where we've kind of started with this whole talk, and we've talked about where that sort of fits in. But we're moving from this disaster recovery belief system to now we're moving into chaos engineering, and then overall, like we're trying to build overall resiliency. And Adrian Cockcroft has a great quote on that. Michael Nygaard, so if you need a primer to chaos engineering and you're like, you can't wait until the new O'Reilly book comes out in a few months, there's a great book called Release It, but you have to get the second edition if you want to check it out, because he added the chaos engineering in the second edition. But it's by Michael Nygaard. He has this quote. He says, chaos engineering is empirical rather than formal. We don't use models to understand what the system should do. We run experiments, and then we learn what it does. Aaron Reinhardt, my buddy, says the security discipline of chaos experimentation is done in order to build confidence in the system's ability to defend against malicious conditions. And so that's what chaos engineering is trying to do. We're trying to experiment. We're trying to run these experiments that span both engineering and security, A lot of places will put it into like a manual opt-out type scenario, but you make valuable learning, and like it's all about the learning. You're not trying to just blow stuff up and break stuff in production, which some of the marketing material will come out on that. But what we're really trying to do is figure out our system operates like this today, and we get a more clear picture of that. And we build these experiments that are controlled, they have a controlled blast radius, and it helps prove out like if our mental model and our understanding of the system is true today, and then like whenever that experiment gets run again later, is it still true? Here's some resources on this. There's Aaron's talk at RSA, there's the Principles of Chaos, there's the Release It book, and then Philip Maddox and Herb Todd both have great talks on deception, so feel free to check those out if you can. It's like you're like, I didn't know I was going to get all this homework. So, I find that is good. So, let's go back to the well here. All right, so when I think of all the arguments the CISO and I have had, I realize how silly most of them were. And it makes me wonder why he wanted to argue over such stupid things. I think I'll go ask him. This is a problem in our industry. Did you want a picture of that? You could see that, okay. This is a problem in our industry where we're kind of like always at war and against each other. And who's ever had this situation where maybe not you, because you're you're at Global AppSec DC, so you're a right-minded individual, but who says, "Oh, those stupid developers." Anybody has a friend that ever says that? Yeah. Okay. Nobody wants to admit it. It's okay if you said it too, it happens, right? But sometimes we'll say like those stupid developers, just in a real cavalier type manner. And then I've had developers tell me, they're like, "Oh, you security people, you just want us to power off the machine and unplug them and just and I'm like, wow, so you think that I don't understand where my paychecks come from? Because I know if we did that long enough, like we would never know, the business, ends, right? But developers see security as so disconnected from the running of the business. They're like, the only way they're going to be happy is if just, you have, a complete, nihilism here, right? So, half the developers say that they don't have time to spend on security. And that's something that they deal with. We've looked at this from 2017, 2018, 2019. The DevSecOps report is always reporting like 50% or 48% there in the background. But developers want to do security. They just find that they often don't have time. And so one of the ways that as a security person we can be helpful, especially in the AppSec world, is like, hey, let's not be blockers, but let's be enablers. Let's help kind of do all these other things in the Measure framework to help us make that happen. Okay, well, I'm going to kind of wind down here. This is the Measure framework again, and we've kind of gone through that. And if you have any, so one of the things we're doing is we're collecting stories about DevSecOps movements or transformations or failures at organizations, and we're working on a book for the same publisher as the DevOps Handbook over with Gene Kim. But you can share your story with us, book@devsecops.org, and we'd be happy to interview you, kind of write up a case study. If you need us to do it anonymously, I guess we could. But we learn, like I said, it doesn't have to be a pure success. It could be like, yeah, we tried it and then like it didn't work. Like that's still really, really valid information for us. So if you have any, if you want to get the slides, you can send me an email at wickett@verica.io, or if you have any questions, you can hit me at Wickett. But now, we're kind of towards the end of the conference, and we have a little bit of break, and I asked Sean about this earlier. I know like Matt Tessaro's here, Aaron Reinhardt's here, DJ Schleen's here, so we thought maybe we could have a DevSecOps support group down here at the front. So if you have any like questions or you need anything, like you ask me, ask these guys. They've done it at like large enterprises. They've put together pipelines at different places. So we'd be happy to come talk about it. We're going to be hanging around by the front for a little bit, but I appreciate your time and thanks, and hope you enjoy the rest of the conference.